First, let's just draw a line. I'm taking 12 centimeter. I'll take 12 centimeter, this, and 6 will be my optical center. And I'll take 2 centimeters as the F1, F2. So this is F1, this is 2F1. This is F2, this is 2F2. So I'll just quickly, this is optical center, this is F1 to F1, this is F2 to F2. Now I will be drawing the lens. It should be, yeah, so this would be fine, little more than O. And then this, and then with dotted lines, it should pass through the center. It should pass through the center. Now when the object is 2F1, so I'll draw the object here at 2F1, A, B. Now there will be two rays, one passing through the optical center so through the optical center the ray will pass undeviated. Now what happens sometimes is, this is just a trick, there will be another ray which will be parallel to the principal axis, therefore the refracted ray will pass through the focus. This we already knew, right? But sometimes what happens is, due to even a 1 millimeter difference, there is a shift. So in order to avoid that shift, what we would do is, we will directly mark a point here, because the object should be, when the object is at 2F1, then the image should be formed at 2F2. So you already mark it in order to avoid, any kind of, mistake, because the object should be exactly here. So by this we have already understood that it should pass like this. So this will make things much more easier. Although it was not required, I just did the reverse process in order to avoid any type of mistake. Otherwise, draw this which is parallel to the principal axis, and once it passes parallel to the principal axis, the refracted ray will pass through the focus, and here they are meeting. So I am going to join this. So the characteristics of the image that is formed. Okay. Nature would be again real and inverted. Since it's real, if it's real, it will always be inverted. Size, if you can see, same size. And position at 2F2. That is why. So as we see, as the object goes nearer to the lens, the size of the image keeps on increasing. Remember, when it was at infinite, it was diminished to a point. When it was very, very far, then it was highly diminished. When it was beyond 2F1, the image was diminished, and now it is same size. So in the next step, when the object will be between 2F1 and F1, this image will become magnified in the next step. When the object is between F1 and 2F1, so let's draw the object. This is the object A, B. Now again there will be two rays. One ray will pass through the optical center, so it will pass undeviated, and the other ray will be parallel to the principal axis, therefore it will pass through the refracted ray will pass through the focus. This is the place where they are meeting. So let's join this. A dash, B dash. So what is the nature? We can see real and inverted. Size is magnified, we can see. and position, it is beyond 2f2, like not at 2f, after 2f2, when the object is at the focus or f1. So we shall draw the object A, B. Again, one ray will pass through the optical center, another ray parallel to the principal axis. Therefore, it will also pass through the, so this is what we are going to get. Can you see? Infinity. Right? These will be parallel. So therefore, nature, real and inverted size will be highly magnified and the position will be at infinity. When the object is between the focus and the lens. So I'll just draw an object somewhere between the focus and the lens. So this is the object AB, and let us suppose two rays. One ray will be going through O. There won't be any deviation. Another ray would be parallel to the principal axis, therefore it will pass through the focus. So it will pass like this through the focus. So if we join the rays backwards, these rays backwards, because can you see this is like kind of diverging. So this was the extra thing. So these are the diverging rays if you see. This was the actual ray. Yeah. So if you extend them backwards, they are going to meet at a point. I'll keep on extending. Yeah, so this is the place where they are meeting. A dash, B dash. As you can see, it's upright, it's erect, and it is the image, the nature, virtual and erect. Why? Because the rays don't actually meet. They appear to be coming from this point. So therefore, they are virtual and hence erect as well. And the size, we can already see it's magnified, and the position is on the same side where the object is, but it is formed behind the object.